I don't know, or I'm quite sure you don't know anything about Amprion, who we are, what we are doing. And just to introduce some slides about Amprion, so we are one of the 4 German transmission system operators. We just transmit power within Germany, and this is more long distance transport for the extra high voltage grid that we have. And so what is very, very important here, we do not generate power, we just transmit the power. And yes, our responsibilities are more or less as well anchored by law. So what is our control area here, and as well our duties and our obligations in order to, to provide a safe grid in Germany. In more detail, what we are doing, this is more in order to characterize our company, to characterize Amprion. So we operate currently an extra high voltage grid, which is 11,000 kilometers long, and which really stretches from the northern part of Germany to the southern part of Germany. We keep the grid stable, and so that electricity can flow every second in an area that serves 29 million people. So it's quite a large obligation that we have. And we as well the basic side, the physical side, in order to enable power trading. So to connect all marketplace and electricity markets from generation to the demand. And we coordinate the power flow not only within our control area, but more or less within Germany and the northern part of Europe. But what currently really drives our daily business in the offices and in our at our premises is our grid expansion plans. So we are currently expanding heavily our grid. We are upgrading our grid heavily in order to integrate new renewable energies into the power system and then more or less into the energy system. And this is more or less in order to pave the way for a climate neutral energy system. So we understand ourselves as an enabler of the decarbonization of the power system because we integrate all the renewables into the system. And in doing this, we as well support industry in order to decarbonize so that we provide electricity, the power that is this is needed in order to as well to decarbonize power production processes, for example, in the chemical industry. And we have here some couple of end users and some couple of direct end users. And this growth really, it drives us currently. Amprion has around now 2,500 employees, and 500 of them are just hired in the last 2 years. So here as well, you can see the growth that Amprion is going, and as well the other TSOs are going as well this way of growth. So which means that our whole business is growing here. And the next slide, I will just as well characterized with that number. So we plan to invest around 22 billion euros in the next 5 years, with just a small comparable small company. And this is really in order to provide the network, the power network, in order to reach the German climate goals. And this number, what is planned that we want to invest, has risen in the last couple of years dramatically. I thought the last number was just around 12 billion. Now we are 22 billion. So large steps in our grid expansion plans, and as well the general price increases led as well to an increase of the number. And in order to subdivide it, around 12 billions are for the integration of onshore renewables, and as well, which is as well typical for Amprion, that 10 billion euros are really to integrate offshore wind into wind energy into the power system of Germany. In doing this, so we pave the way for the decarbonization of the power system. So we do here something for the whole system, but we want to be as well sustainable for our own, for Amprion. And we are a little bit proud of that. I can show this next slide that we recently got a good score in a rating for sustainability for our way to manage our ESG risk. So from Sustainalytics, we got a quite good rating currently with a negligible risk, which is in a range of the utilities. So we are in the industry group the fifth of 700 ones, and in the electric utility category we are now the second, and as well received quite a good sustainable Fitch rating with a 2. And yes, in doing this, CO2, the carbon footprint is very essential for sure. So we as well really concentrate on our own CO2, on our own CO2 carbon footprint. Sure, as well, because we have to be here transparent. We have to report our emissions due to the CSRD. But as well, because we are expected from our stakeholders, from our shareholders as well, in order to do here something in our company, as well in our, directly within our companies. And as well, we are sure, as others, we have submitted emission reduction targets to the SBTi. This graph just gives a picture which is quite old. It's from 2020. And as well, already there, climate protection was highly ranked in our materiality analysis, as well with the relevance to stakeholders, as well with the relevance to our business. And it is more or less in the same area of our core business to provide a safe and a stable grid. Okay, but how does our CO2 balance look like? Where are our large positions in our CO2 balance? I will start with scope 1 and 2. So here you can see one dominant element of our scope 1 and 2 balance, and this is the coverage of the grid losses. So we have to buy electricity in order to cover for our grid losses, and this really is the most impacting factor for scope 1 and 2. And you can see, okay, here's some decreasing trend in it over the last couple of years, but as well some fluctuation. And this is because we have to buy the electricity from the market. And so we are depending on how the CO2 intensity of the power generation evolves. Further emissions like buildings, vehicle fleet, and SF6. SF6 as an insulating gas in our substations are quantitatively insignificant in our balance, but we as well defined measures in order to decrease this kind of CO2 emissions, like for example more energy efficient buildings at the headquarters, for example, would really drive down our CO2 balance already there for this category. And what about scope 3? Here we have two main points. This is capital goods, this is purchase goods and services. And then you understand what is lying in these two categories. It's our grid expansion. So it's really that we need for our grid expansion that we need a lot of steel, a lot of aluminum, a lot of copper in order to expand the grid, and as well the construction works in order to really, extend the grid. And as well here, other categories have more or less a secondary role. Here, the fuel and energy related emissions are around, some 12 to 20%, and these are more or less directly connected to the grid losses. Because here we balance more or less the fuel and energy related emissions due to the coverage of our grid losses. And what is as well some characteristic point of our balance is that downstream activities are not relevant for us as an Amprion, because our product is more or less a transmission of electricity, which itself has no CO2 emissions for our clients. Okay. Now is the question, how does scope 1 and 2 with this large pillar grid losses compares to scope 3? And this is here the balance for the last year, where you can see that as well today scope 3 is very relevant for us, so around now 40%. And as well as scope 2, which is more or less to 95% the grid losses. But in future, when we look into the future, we will see that the scope 3 emissions will absolutely increase because we extend our grid more and more. And we see that our scope 2 emissions with the grid loss related emissions will be reduced. Why is this? just a short look into the future. Yes, what determines the CO2 emissions due to the coverage of the grid losses? This is first of all the sum of the grid losses. We expect that this will heavily increase because of the higher utilization of the grid. So we have more power transmitted within Germany from north to south. You know, here the problems. And as well, we have longer transmission distances, and we have the commissioning of additional power lines, like, for example, offshore grid connection systems. But however, the CO2 intensity of the electricity that we have to purchase from a market will be reduced. And this is because the overall power generation will be decarbonized, and there we have a direct impact on us. We do enable this reduction of the CO2 intensity by our grid expansion. So really with our work that we expand our grid, that upgrade our grid, will directly lead to a reduction of our scope 2 emissions. So really we have here some interconnections between these parts. And yes, as written below, so the decarbonization of the power sectors, as we see it in our projection, is more effective than the increase in the grid losses. So we expect we will have currently around 3 terawatt hours of grid losses will dramatically increase, but here the CO2 intensity of the whole power generation will decrease more, so that CO2 emissions through the coverage of grid losses will be decreased. And in scope 3, our goal was here more or less, in line with SBTi requirements that we want to reduce. It's a near-term target for the next 10 years that we want to reduce the scope 1 and 2 emissions of 63%. Okay, what about scope 3? As I said before, we have large grid expansion plans in our for our system. This map more or less sketches all the lines that we want to build. So large earth cables in the earth, and as well offshore connection systems and some new overhead lines. And yes, for us, the scope 3 emission, the amount is already essential today for us, but it will increase in absolute numbers. And that's very challenging for us in order to really determine an absolute CO2 reduction target for scope 3. And we decided for the near-term target to use the physical intensity target to say, okay, we compare our scope 3 emissions with the annual grid expansion. And on the basis of this, we defined our reduction target, which means that we want to reduce almost 60% in scope 3 within the next 10 years. And yes, in order to do this, what can we do? And for us, really transparency about the carbon footprint of our goods and services is here the key. I think this is, very familiar for you. Currently, we use, in a status quo, we use secondary data for the used material, for the, for the construction works. And yes, we have with that kind of information, not a specific information, depending on the supplier and locations of the production of all the materials, and especially band-based emission factors are very imprecise. So that's why we want to switch here to primary data. We want to do this in a further development. So really that we want to collect data from our suppliers, from our providers of services in order to improve the data quality, and that we as well have some kind of control capability what will happen in our scope 3 balance. And yes, in order to consider supplier specific CO2 emission factors, that we as well, for sure, that we include as well as supplier progress in our own CO2 balance for sure. And what we want to do as well, and we do that as already, that carbon footprint is then an important decision on when we award contracts for our suppliers. Okay, but really primary data, this is more or less an area of development, sure, for us. We are as well here at the beginning of the journey. And currently there exists no common framework for data passports for the CO2 footprint of the materials and as well for the grid construction works. And this means there's a general lack of availability, a lack of comparability, and as well of the validation of the primary data that we get when we send a questionnaire to our suppliers. And yes, we try to find a way here in order to really have more or less a common framework, common database for this. Then next point is, here's some question marks on my slide, that essential elements of our grid expansion projects are turnkey projects. Here's one example. This is more or less an offshore converter platform collecting all the wind power generation offshore. And this means this platform has around 40,000 tons of steel in it, and it costs around 2 billion euros, which describes more or less the huge impact on the CO2 balance, as well the huge complexity within it. And really to say, okay, because it's a more or less turnkey projects, what about the subcontractors of Tier 1? How to get the data from him and to get really good data from him. And as well construction works where we work together with small suppliers. And here as well the question, how are they able to really provide us with good primary data? And last but not least, currently we face a very tight market with relatively few suppliers and limited production capacities. I don't know whether you knew it from a newspaper, that we really are, yes, looking for production facilities in order to really build, for example, these offshore converter platforms. There's only one in Europe, which is providing with that currently, and it's really hard to contract here suppliers with that. So really a difficult framework in order to say, okay, carbon footprint is more or less then a decisive decision criteria when awarding contracts. We hope that this situation will be better, and as well because we are to a certain extent as well legally binded in order to really provide the grid extension, especially in offshore area. Though we have to build out a grid, in a certain time path, which we have to meet. So we have no time in order to do that, in order to evolve that with that, development. Okay, key takeaways. How can we as a TSO can achieve our reduction targets? With the focus is more or less the grid losses in scope 2. This is with the grid expansion itself, we enable the integration of renewables into the power system and the power market. And by buying power in order to cover for our grid losses, and by using then the decrease of the CO2 intensity of the power generation, as well our CO2 balance in scope 2 will decrease. And next point is scope 3. So currently we want to go away from the accounting on a secondary information basis, going to primary data, improving data quality, and as well to use this as decision criteria when awarding contracts. Okay, many thanks for your attention, and looking forward.